Nowadays, when we buy something online, we are used to next day delivery. But have you ever wondered how all these purchased items are being picked within a warehouse? My name is Bram and I developed a machine learning algorithm to predict when and how these orders should be picked in a warehouse. I conducted my research at Van der Lande, a logistic automation partner within the parcels, airports and warehousing market. For the warehousing market, they developed a new warehousing concept with a fully automated system in which shuttles pick your items, and this is combined with a manual storage area in which pickers walk to collect your items. Together with workstations, there are several routes in which your order can be picked. For this specific warehousing concept, it was unknown how orders should be picked in such a way that they are shipped on time and delivered at your door the next day. And this is where machine learning came into place. We use deep reinforcement learning to come up with a strategy to determine what the optimal route is for which order. So in reinforcement learning, we mimic the environment and we determine what is the best route for which order. So the algorithm can choose to pick a certain order via a certain route. It sends this to the simulation model, and this provides feedback to the algorithm whether or not this order was shipped on time. It remembers this, and it does this over 1 million times until it has performed or has obtained the best strategy to fulfill these orders. To benchmark our algorithm, we use several heuristics, and we evaluated it on 2 scenarios. A more static scenario in which we release orders every 60 minutes, and they have a cutoff time between 60 minutes and 2 hours. And we had a more dynamic scenario in which we release orders every 15 minutes, and these orders had a cutoff time between 15 and 60 minutes. Eventually, when we compared the results, the reinforcement learning was able to find a suitable strategy for both scenarios. For the static scenario, it outperformed the heuristics, and for the dynamic scenario, the heuristics were slightly better, but the results weren't significant. So conclusions is that the reinforcement learning is able to find good strategies for these systems, for these scenarios. But the overall conclusion would be is that if you have lots of processes, lots of combinations, lots of constraints, and you're trying to find the optimal strategy within this complex system, reinforcement learning is your way to go.